We're going to take a look at some review problems. We're looking at quadratics. In quadratics, we've been solving those quadratics, we've been factoring the quadratics, and we're also graphing the quadratics. So taking a look at some review problems, let's start by doing a solve by graphing problem. So looking at each one of these two, I want to get y by itself first. So looking at this first one, if I would take this equation, and if I were to take and subtract off the 6x to get it on the other side, so negative 3y is equal to negative 6x plus 9. Now divide everything by negative 3, so you're going to have a y here. Negative 6 divided by negative 3 is a 2. 9 divided by negative 3 is a negative 3. So there's my first equation. My second one, I just subtract x squared from both sides. I get y equals the opposite of x squared minus 1. Let's put both of them in our graphing calculator. If you put them in your graphing calculator, what you want to do is take a look at where these two graphs intersect. So if I hit zoom and standard here, which is number 6, here's my line, which is my first equation, and my second equation is a parabola. So I've got a linear quadratic system that I'm solving. It has two solutions because there's two intersection points. Now to look for the intersection points, what I do is I hit second calculate, and I go down to intersect, which is the fifth one. And now I have to tell the calculator which is my first function that I'm using, and it's 2x minus 3. What's my second function I'm using? It's opposite of x squared minus 1, so just confirming it by hitting enter twice. And then you've got to use your right and left arrows to get the graph close to where they intersect, because it wants to know which one of these are you looking for the intersection point. Now it might only be one of them, but it always wants you to guess about where it's at so it can do its calculations, and it gets the intersection point as, we'll round to one decimal point, as 0.7 comma negative 1.5. So we'll do 0.7 and negative 1.5 is my first intersection point. Now let's look for the second one. So we're going to follow the same steps for this. And so I'm going to go with second calculate. I go down to intersect. And this one I'm going to, same first curve, the first function is 2x minus 3. Second function is opposite of x squared minus 1. And now to guess, I need to hit the side-to-side arrows. Don't use the up and down ones, just right or left, and get that cursor over close to where the second intersection point is. Hit enter, and for this I get negative 2.7 and negative 8.5 for my x and y. So negative 2.7 and negative 8.5. My 2 points of intersection. That's using our graphing calculator in the graph to get those intersection points. All right, let's go ahead and do one by substitution instead. So this is solving a linear quadratic system by substitution. So I'm going to start by getting this and looking, well, first of all, just a hint. You want to probably replace the y on this with something else, because if you try to replace the x, sometimes the problem can be needlessly complicated by having to square things and multiply. So the best bet to do is to take, I'm going to substitute this y, because it's already by itself, in the other equation. All right, so first of all, I'm going to put that over here. So I'm going to have 3x squared plus 9x minus 8. It's my first what y is equal to, then plus 8 is equal to 5x. Now, I'm going to go ahead and take this plus 8, negative 8, and I can simplify that. So 3x squared plus 9x equals 5x. And now this one, I think that my best option here is going to be to factor, because I noticed that I've got less terms and everything has an x in it, so I'll be able to take out a common factor. I'm going to try factoring. You do have the option of solving by completing the square quadratic formula. So let's go ahead and subtract 5x. I get 3x squared plus 4x is equal to 0. I can factor out a greatest common factor, which is an x. So I have 3x plus 4 equal to 0. And now I'm going to set each factor equal to 0. X equals 0, that part's done. And then this one, 3x plus 4 equal to 0. So 3x equals negative 4, and x equals negative 4/3. So these are my x values. I now have to get the y values for my system. So probably best to go back to the linear. You could square them and multiply if you want to, but going back to the linear is probably your best bet. So for this one, I'm going to put in x equal to 0. So y plus 8 equals 5 times 0. So I'm going to subtract 8 because that's y plus 8 equals 0. Subtract 8 and you get y equal to negative 8. So 0, negative 8 is this first point of where they intersect. Now this one's going to be a little more complicated. I'm going to put it into the equation. I'm going to have to deal with the fractions. So I'm going to just do it up here. So I'll take this value and put it in for x in this one. So y plus 8 is equal to 5 times negative 4/3. Now just a reminder, when you have fractions and you're multiplying, make the 5 into 5/1. And so what you're going to have on this side is you're going to have negative 20 because you multiply the 5 times the negative 4, and then the 1 times 3, and you get a 3. And then on this side, I'm going to make that 8 into a fraction that has the same denominator. So think of this as 8/1, and if you multiply it by 3/3, you're going to get plus 24/3. So common denominator for this one is the thirds, so you get 24/3 when you do that. Now I'm going to subtract 24/3 from both sides, so negative 20/3 minus 24/3, and you get negative 44/3 for an answer. So my ordered pair here is going to be negative 4/3, comma negative 44/3. Exact answer for the solution for that one. All right, let's go down to these. Next one. So this one we're going to solve by factoring. So we already reviewed factoring a little bit here, but this one is going to be a different pattern. Notice that these two, there's no GCF to take out, but we are going to look at it two terms with a minus in between, difference of two squares. So we're going to factor it into two parentheses. Difference of two squares has a minus and a plus in its pattern. So you want one minus and one plus. You can flip-flop which one you want. And then the square root of 5x squared, 25x squared is 5x. So I put that as the first for both. And the square root of 9 is a 3. So 5x minus 3, 5x plus 3. Set each factor equal to 0. So 5x equals 3. X equals 3/5. And then this one, 5x plus 3 equals 0. So 5x equals negative 3. X equals negative 3/5. So those are my two answers for this one. Now I'm going to solve the exact same problem. Notice that if I add 9 to both sides, it becomes this problem. But I'm going to solve this one using square roots. Let's take a look at a different method for doing this. When you have this kind of pattern, you add 9, you get this equation. And what we can do is say, hey, let's take this and divide by 25 first. Let's get the square x squared by itself. So 9/25. And then we're going to take the square root of both sides. Technically, the square root of x squared is absolute value of x, but we skip that step. But we have to include a plus or minus on this side. And then we take the square root of 9 over the square root of 25. When you take the square root of a fraction, you can write it as the square root of the top over the square root of the bottom. And that just becomes plus or minus 3/5, which is the exact same answer that we got over here. I think it goes a little quicker if you use those perfect squares for a pattern like this. All right, let's look at the next couple problems. This one we're going to solve by factoring. So the first step to do is to get 0 on one side. So we're going to add 5x to both sides. We're going to put it in order What I mean by order is you want the quadratic, the linear, and the constant. So you put it in that order so we can factor it. This factors, we put a parentheses in with an x and an x. Two numbers that multiply together give you the 6. Add to get the 5, that'd be a 3 and a 2. Set each factor equal to 0. Solve each one of them. And you get -3 and -2. And just to note, this is okay to write it in that form. Another way you might see it at times, just to keep you familiar with it, is we might use these braces like we used for set builder notation. This is a set. This is the solution set of the answers. So you just put them both in braces. That list tells us that the solution is -3 and -2. Let's solve this one by completing the square. The first step you do for completing the square is to add 50 to both sides. So we're going to get x squared minus 12x equals 50. Then you're going to take half of this middle term, which is -12, and you're going to square it and add it to both sides. Well, half of -12 is -6. Squared is a positive 36. So we get 36 here. And we're going to add 36 on this side as well. So over here, we're going to have 86 as our, what those two add to. Now over here, the perfect square that we've created by completing the square, it's going to have an x here, and then what the half of that -12, that's what goes in here as the factorization. Because this factors into x minus 6, x minus 6. We created this by doing this process, so you got the exact same factors there. That's called a perfect square. Two of them gives us a perfect square. Now we can solve it like we did this one up here with perfect squares by taking the square root of both sides. So x minus 6 equals, remember your plus or minus, the square root of 86. And then we add 6 to both sides, so put the 6 in front. It just helps so that we don't confuse it with the plus or minus. It's the square root that has the plus or minus to it, not the 6. Okay, we should look for perfect squares in 86. There are no perfect squares in 86, so this is our answer. Two answers, one plus, one minus. All right, let's do this one with the quadratic formula. So this one we're going to get is, again, you want to get 0 on one side first. Our quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's something you should have memorized. Sometimes it's helpful to just do the discriminant first. That's the b squared minus 4ac. Get that out of the way so that it's not getting in the way of our problem. So a is 3, b is -2, c is equal to -3. Let's go ahead and do this. We get b squared minus 4ac, the discriminant. So you square the -2, subtract 4 times 3 times -3. So that's going to be 4. And then minus, notice this can be 12 times -3 is equal to negative, let's see, so 12 times -3 is -36. So you get 4 minus a negative is 4 plus 36, or 40. So our discriminant is a positive number. It's not a perfect square. So that means we're going to have real answers to this. If it had turned out to be a negative, we'd have non-real answers. They would be imaginary, have an imaginary part to it. This tells us that this is going to be a real number. It ends up being irrational numbers because it's not a perfect square. Now let's go ahead and put that into the quadratic formula. So x equals the opposite of b, so opposite of -2 is 2, plus or minus the square root of this 40, all over 2 times a, so 2 times 3 is 6. Now we look for a perfect square in 40, and 4 goes into it, so we make it 4 times 10. and that's over 6. So we get 2 plus or minus 2 square roots of 10 over 6. Now, we can reduce from here. If you can reduce in every term around the pluses and minuses in the top and also in the denominator, there's a factor of 2 in everything. That means there's a GCF I can take out of the numerator and reduce it with that denominator, a factor of 2. So this gives us, if we reduce everything by a factor of 2, taking 2 out of that, we'll be left with 1. Taking 2 out of that, we'd be left with 1 square root of 10. We don't have to list the 1 there because we have the square root of 10. And then reduce the 6 by a factor of 2 and you get a 3. So 1 plus or minus the square root of 10 over 3. Let's factor this one to solve. So we're not actually solving. So notice the difference here. This one just says factor. So up here where we were solving equations, this has an equation, this has an equation, this has an equation. We solved those. This one, there's no equal sign, so you just factor it and stop. All right, so I'm going to use the box method for this one. For the box method, we put 3x squared in this box. We put negative 20 in this box. 3x squared is pretty simple choice because it only can be 3x and x. And so for the negative 20, we have a lot of options. We have 20 and 1, 10 and 2, we have 4 and 5. We have to make one of them negative to get it to be a negative 20. So let's go ahead and use plus 5 and a minus 4 here. That'll multiply to get negative 20. X times 5 is 5x. 3x times negative 4 is negative 12x. Notice that the 5x and the negative 12x, they do not add to that 11x. So we have to try again. Make this box a little bit bigger. So for this one, 3x squared still goes here. Negative 20 goes here. We still only have 3x and x as a choice for this. But let's flip-flop the negative 4 and the positive 5. Negative 4 here, positive 5 here. And let's go ahead and do x times negative 4 is negative 4x. 3x times 5 is equal to 15x. Those two, when you add them together, you do get that 11x in the middle. So we've just organized our work to come up with the solution. The factorization of this is going to be 3x minus 4 times x plus 5. Okay, and don't try to solve it because there's no equation to solve on this one. All right, for this one, let's go ahead and get this into vertex form and then state all the information that's requested. So if we have y equals x squared minus 6x plus 4. So to get this into vertex form, what you have to do is you have to group these two together. So I'm going to leave a blank on this side, group the x squared and the minus 6x together, leave a blank, and put the plus 4 out here. Now, we want to do the same process we've done with completing the square. Take the half of the middle term, coefficient, square it, and add it here. So half of negative 6 is negative 3. Squared is equal to 9. Now here, if we had a number factored out in front, which we don't here, but part of the process is if you factor out a number, you'd have to take whatever number here is times that 9 to see what you multiply on both sides. Here it's just 1 times 9 is equal to 9. So I get y plus 9 equals, and this, when we completed the square, remember, it's the half part that's an x minus 3 for half for this. And now we're going to go ahead and subtract 9 from both sides. Y equals x minus 3, the quantity squared. And then if you subtract 9 from the 4, you get minus 5. So our vertex here, when we do this, is we're going to have the ordered pair 3 comma negative 5 for our vertex. For this one, we're going to have, let's go ahead and state the information down here. So it asks for the vertex. It also asks for the axis of symmetry. The axis of symmetry is x equals 3, just the x value right there, but you have to put it as an equation because it's a line, axis of symmetry. Because of the first value is equal to 1, it opens up. Because that opens up, we're going to have a minimum, and the minimum value is going to be the y value at the vertex. Right? We want the domain and range. So the domain is going to be all real numbers, negative infinity to infinity. And then the range is going to be everything above this minimum value. So my range value is going to be starting at -5 and going off to infinity, because it opens up from there. Now this says, where is the graph positive and negative? Okay, so for that one, what you'd have to do is you'd have to come up with where the graph crosses the axis. And so for this, we need to know, when is this equation equal to 0? So looking at that equation, we're going to come up with two numbers. And so if we have 0 equals x squared minus 6x plus 4, let's go ahead and complete the square on this one really quick to come up with the answer. So subtract 4 from both sides, we'll get -4. So you get x squared minus 6x, group those together, take half of the -6, square it, and you get the 9, plus 9, add 9 to this side, and so you'll get 5 equal to x minus 3, the quantity squared. Take the square root of both sides, so you get plus or minus the square root of 5 equals x minus 3. Add 3 to both sides, you get 3 plus or minus square root of 5 equals x. So we want those two values. So if we look at this, we get, in our calculator, let's go to the calculator portion. So on this, we're going to go with 3 plus the square root of 5. That's going to give us about 5.2. We're going to round on this one. So, so x is about 5.2. And then the other value, let's do 3 minus the square root of 5. That's going to give me about 0.8. Now, if you think about what the graph would look like on this, then notice our vertex here. Our vertex is going to be at 3, -5. So 1, 2, 3, down at -5. So down here. And then where it crosses just past 5, and it crosses just before we get to 1. So these 2 points, 0.8 here, and then also out here at 5.2, those are where it crosses. So notice where my positive and negative ranges are. It's going to be positive when we go from negative infinity and we end at 0.8. And then also it's going to be from that 5.2 and it goes off to infinity for the rest of it. Now for the negative range, notice it's negative right here where these go right here. This is the negative range, and that's just between our two intercept points. So it'll be negative from 0.8 to 5.2. Okay, so what we've done is we've reviewed over how we solve, how we factor, and how we graph to do different problems. Making sure that you follow the different procedures, things like completing the square, quadratic formula, and factoring will help you get to your solutions for these quadratics.